All right, hi everyone. So this video is going to go through the short guided notes about inter and intramolecular forces. So this is lesson 3 of unit number 4. So we're in bonding. And so the difference between, there are two types of forces. You have intra and intermolecular forces. Now an intramolecular force is a force between atoms, okay? So it's a force between atoms that holds the molecules together. So it holds the molecules, ionic bonds, or your ionic forces, and covalent forces, okay? So we've seen this drawn in our previous lesson 1, where we had an ionic bond that looked like this, maybe between potassium and chlorine, where they have the positive cation and the negative anion are attracted to one another, and so that creates that ionic force, which is intramolecular. Or you might see something for a covalent bond like this, okay, showing that these electrons here are being shared between the hydrogen and the chlorine, and that's what makes it a covalent bond and a covalent force. And so that's the intramolecular force. It's just in the atom and inside the molecule. But an intermolecular force is a force between neighboring molecules, okay? So this is between multiple molecules. So an example of this, so they're given specific names, but I'm mostly going to focus on like drawing what that looks like. So for example, if you have water, so this is the Lewis structure for water. What happens is water is polar covalent, and so water has a partial negative charge on the oxygen and a partial positive charge on the hydrogens. And so what happens is that those partial positives and partial negatives are attracted to one another. So there is a attraction, and it's temporary, between those two things. So we have molecule number 1 right here, and we have molecule number 2 right here, and there's this attractive force that's between them. So if I were to draw a third molecule of water, okay, then this molecule would experience an attractive force. Well, actually, if we're going to be correct, it would need to have the oxygen turned. So let's see if I can get this to turn around. Will it turn? Nope, can't get it to rotate, so I'll have to just erase it. All right, and I'll draw the water molecule sideways. So the oxygen is always attracted to the hydrogen. That's kind of how it works. The positive is always attracted to the negative, and so there would be a attractive force between these molecules. So this right here is the intermolecular force. Okay, and it has a specific name, but we're not going to get into all of that. So we can see that the water is going to have an intramolecular force right here because it's covalent. Those electrons are being shared between hydrogen and oxygen. But then each water molecule itself is attracted and connected to one another through intermolecular forces. Now, the intermolecular forces are going to be what determines the physical and chemical properties of the substance. Okay, and so when we look at these physical and chemical properties, there are 3 that we really want to make sure that you know what they are. So melting point, which we tested in our lab, is the temperature that a substance changes from solid to liquid, which I should have given myself a little more room there. Now the impact of the intermolecular forces, which intermolecular forces is often abbreviated as IMF. Okay, so these IMFs, if you have strong intermolecular forces, that means that you are going to have a high melting point, which melting point is often abbreviated as MP. So you're going to have a high melting point because it requires a lot of energy or a high temperature to break those forces. And then if you have a low melting point, or excuse me, if you have weak intermolecular forces, sorry, it's bringing up my settings. I don't know why. Okay, sorry about that. If you have a weak intermolecular force, or IMF, that means you'll have a low melting point. Because keep in mind what melting is. So if I have those water molecules again, okay, if I have water molecules as a solid, okay, then they are very compact. Okay, these water molecules are here. Okay, they're all very close together, things like that. So in order to get them to separate, okay, they would need to weaken these attractive forces that are between the molecules because you want to separate them out into a liquid. Now, boiling point is similar to melting point, but it's abbreviated as BP, and it's the temperature that a substance changes from liquid to a gas. Okay, and so again, similarly to melting point, if you have a strong intermolecular force, then you're going to have a high boiling point because again, it takes a lot of energy to change them. And if you have a weak intermolecular force, then you have a low boiling point. Now, the main difference between melting and boiling point in the intermolecular forces is when you have melting, which we can add this just kind of above it. Melting, it weakens the intermolecular forces. It doesn't break them completely because you know when you pour a liquid that the molecules are still connected together, right? You don't pour it and then some go down and some float up in the air, anything like that. But when you boil something and it goes from a liquid to a gas, okay, this is when all of the intermolecular forces are broken completely. And this is why gases can spread out throughout the room. Now, viscosity is a liquid's resistance to flow. All right, so think about honey versus water. When you pour honey, that would be very viscous, or it has a high viscosity. So if you have strong intermolecular forces, then you have a high viscosity. And so this means that things flow slowly, okay? So honey, when you try to pour out honey, it's very slow. But if you have a weak intermolecular forces, okay, then you're going to have a low viscosity, which means things are going to flow fast. Okay, so you want to keep in mind what all of these mean. And then that's pretty much it. There's a lot more detail that we could go into, but this is all that's required at this level of chemistry in Gwinnett County, so we're going to stop there. And then you have 2 practice problems, okay? So keeping in mind boiling point and viscosity, you want to practice these and check with your neighbor to see what you got. And you can also pause the video and then press play when you're ready to go over the answer. Okay, so if we look at these practice problems, it says 2 students carry out a boiling point investigation for 4 substances. What can you conclude about the strength of the intermolecular forces based on the boiling point data below? Well, we know that if I have a strong intermolecular force, that means I have a high boiling point, right? So this means I can rank them. The highest boiling point I have is sample 1, and the lowest that we have is sample 4, or chemical 4. So that we can say that sample 1 has the highest, or has the strongest, because the goal is to talk about the strength, has the strongest intermolecular forces, because it has the highest boiling point. And really, to finish this out, I would complete that for all 4 of them. Or we can say that sample 3, and then sample 2, and sample 4 is last. Like, you could rank them. Okay, so sample 1 would have the strongest intermolecular forces, and this one would be the weakest intermolecular forces. Okay, and you can do the same thing for viscosity. So number 2 says viscosity measures the chemical's resistance to flow. A group of students measured the time it took for 3 liquids to flow from point A to point B. Rank the chemicals from lowest. So they want us to rank the chemicals from lowest to highest and explain why. So if something took 1 second to flow from point A to point B, option B, or chemical B, took 10.7 seconds, and option C took 4.37 or 3 seconds. We know that this one has the highest viscosity because it took the longest to flow, whereas this one had the lowest viscosity. And so this tells us that the order of the chemicals from lowest to highest intermolecular forces is B, C, A, because the longer it takes to flow, the higher the viscosity, and the stronger the forces. So you should be able to draw that conclusion for yourself. Hopefully this video helped, and if it didn't and you still need more help, maybe check out some of the other videos on this playlist.